MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
Peter, we're at DMG MORI today, great facility. Can you tell me what today's all about, please?
It's really a slightly different approach from the normal sort of CAM event that we would run. In the past we've focused mainly on actual demonstrations on the computer showing different strategies and so on and so forth. But what we want to do today is actually show some of the results, show what actually happens on the machine tool with some of the advanced strategies that we've got at Delcam, and what better place than here at DMG, where you've got very wide range of different types of machines, from 3-axis eco-mill type machines at one end of their spectrum up to the very high-end 5-axis machine tools like the DMU at the other end. So again, as I said, a very wide range of machines which we can show the different capabilities of our different software programs.
Sure. What demos are we likely to see today?
Well, the two main demos that we're running in terms of the machining side of things are one which is feature cam, which is this part we can see here, and a classic type of feature cam part, a lot of different features, so different types of holes, some tapped, some drilled, some threaded and so on. Again, area clearance with the vortex that we're able to show as part of this demonstration. The machine it's running on is one of their eco line machines, the eco mill, so lower cost DMG machine, but again showing with feature cam and with the right choice of tooling you can get some pretty impressive results, even at what by DMG standards is a relatively low cost machine. So at the other end of the scale we have the 5-axis, high-end 5-axis machine, probably for which DMG is better known. And in this example, what we've got is a very complicated shape. It's called a Möbius ring. So basically what happens is the shape of the ring goes from outside to inside and then back again to outside, back to inside in a continuous loop. And even with a very sophisticated 5-axis machine, a very difficult part to produce. In fact, we've some new technology within PowerMill which we call advanced verification and simulation, and according to the guy who programmed it, it would have been virtually impossible to do without this latest development, particularly because you've got a constantly changing engagement angle as you go around, so you're constantly having to edit the tool axis angle in order to avoid collisions and maintain the very high quality surface that you can see here. And obviously, even with the best programming in the world, you still need a fairly sophisticated 5-axis machine such as you can get from DMG in order to be able to machine the part in the first place. So as I say, it's quite a challenging 5-axis machine part and showing off what we can do at that end of the spectrum.
Peter, this is the third demonstration of the day. What's it all about?
Well, this again is a different technology. It's called Power Inspect on machine verification. And what we're doing here is checking a part, finding some errors that we've deliberately introduced into the program to create errors on the part, and then recreating the tool paths in order to correct those errors. As you'll see when you get onto the demonstration, what we're doing is we're creating a probing path using Power Inspect, which will check the part that's been machined. We'll then highlight those errors, regenerate a new program to correct the errors, and then run it back on the machine. And it's really highlighting the big benefit of this on-machine verification is that the checking's being done where you can actually do something about it. So it's been done on the machine, you can remachine it, you don't have to take the part off the machine, inspect it somewhere else, and then try and clamp it back in exactly the position it was in originally before you can do the corrective actions. So as I said, it's doing the correction on the machine.
Okay, so it reduces operator intervention, no need to take the workpiece away from the machine tool. Sounds great.
Okay, well, as you said, it's saving time is the key thing, because if you've got to take the part away, there's no guarantee that you'll be able to inspect it. You might be in a queue of parts that are waiting to be inspected. Keeping it here means you can do the inspection straight away, find the mistakes straight away, and put them right straight away.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.